I'm delighted to be here today with someone who has written a fascinating book, and going to give you I've got it on Kindle right now. It's Jordan Peterson's Christ Revealed. And you can see that the author on the top says a believer because he has written this anonymously. And I am very excited to talk about this book. I've read the whole thing. I find it many very compelling ideas in there. And the author of this book and I are going to try to approach this very complicated subject because the book is mainly about a perspective that arises out of Jordan Peterson's maps of meaning and how it connects to many other frameworks that are available to us that can help us to see deeper things. And before we get started, I want to just run through the frames that you talk about in the book, because they're zoning in on many of the things that we've talked about on this channel. And I think it'll help people kind of wrap their heads around why it's such a complicated topic. So you're weaving together Peterson's two books, Beyond Order and Maps of Meaning, and many of the things that he's talking there around the idea of meaning being that process that takes place at the boundary between chaos and order. Mm-hmm. And then James Gleick's book on chaos, where he's talking about complexity, chaos theory and complexity theory, which we've done a lot of work on here. And in particular, the one that I think would be helpful for us to talk about is the aspect of the Mandelbrot set. And then you bring in Raphael's 4 paintings in the Vatican that talk about revealed truth, natural truth, beauty, and good. And we've also done a lot of work on that on this channel, talking about those things. And then something called the responsibility process, and the author of that I have forgotten, Christopher Avery. And the responsibility process breaks the world out into 2 broad categories. Well, one very narrow category and a very broad category. The narrow category is responsibility, and the broad category is coping mechanisms. And I thought it was a brilliant picture. And the way that you laid these over on top of maps of meaning reminded me of the struggle that I had when I first started reading maps of meaning. And all of a sudden, as difficult as it was, it became crystal clear to me what he was talking about, because I had this lens of making art, and the lens of making art and the principles of creativity just translated that book to me. And so the whole thing opened up to me in the same way that I think things opened up to you through these lenses that you were using to zone in on and explore Peterson's perspective on Christ and what that means to us in the world today in navigating meaning. So you thought maybe a good way into this would be through Wolfgang Smith's icon. And as you know, he's been on here several times, and we've talked on other episodes, we've talked about the icon with other people. And I think that would be a good approach to take too. And before I go any further, I want to mention that I found you through Jordan Hall, because I watched your most recent episode with Jordan Hall and listened to the whole thing with great interest. And I will link to that in the description section so people can hear that as well. So I'm going to bring up, I'm going to share screen here and bring up this picture of the icon. Whoops, brings up a whole lot of other junk as well, unfortunately. Okay, can you see this now? Is it obstructed by anything?
Yep, that's good.
Okay.
So I thought I'd use this as sort of a starting point. Are you familiar with Jordan Peterson's basically interpretation of the Egyptian mythology, where you've got the story of Horus and Osiris and
Yes.
Set, and he makes a point of talking about, I think it's Osiris being the father, gets killed and cut into pieces, let's say, and scattered throughout the underworld. And Horus, rather, when he ascends to power, let's say, rather than leaving his father dead, goes into the underworld, resuscitates him, brings him back to life. And then the key thing is that they join together and rule. And Jordan Peterson's always using this sort of hierarchical pyramid structure to point to the way that they unite again and they're stronger together. And I've never heard him say this, but I assume that he's got at least an implicit understanding that we currently live in a time that's where that mythology applies, where we have basically a god that has been killed, as Nietzsche might put it, and is dying or dead. And we've got this new god, the god of science, that resembles Horus, the god that has this clearer sight and can see further and clearer, like and so we're in a position right now where we've got this new god of science that's risen up, but it's sort of like I suppose Set in the Egyptian mythology, where it's divorced from its roots, from the father. And so at the current time, I think that mythological structure helps us to see where we stand, where we've got something that's basically been set aside and a new thing that's taken its place. But now there's a disconnect, and we're no longer attached to our roots. And the challenge, and I see it happening all around, is that they seem to be getting closer and closer together. And I think they've now, science has gotten to the point where it now intersects or converges, let's say, on God, really. So what I mean by God would have to be defined. So this icon, as Dr. Smith puts forward, is basically an icon that's supposed to represent the cosmos. And I've listened to him, and I have to admit that I don't really go along with his interpretation of it, but I like the icon itself because I think it can actually help us visualize the three major revolutions that took place in physics in the 20th century. If we look at this, we can see, let's say, the whole, and with that, we can look at general relativity, or relativity in general, which is basically the container in which we exist. And I believe Dr. Smith talks about we live on the perimeter, and that sort of reminds me of, and I mentioned this book to Jordan, the Life on the Edge, which has to do with life at the edge of basically the distinction between the quantum world and, let's say, the classical physics world. And then finally, there's the idea of chaos, that that allows us to make the connection between the small scales and the large scales. So what I was hoping to do is kind of walk through those revolutions and be guided by the minds that brought those revolutions about. So I was hoping that we could take a look at, or examine, let's say, Einstein's, let's say one of Einstein's thought experiments. So are you familiar with his thought experiment where you have basically one observer on a train platform and another observer on the train conducting an experiment, basically? And the experiment consists of a clock, a light clock. So you've got a mirror, and we'll put the mirror, let's say, at where the bottom dot is. The bottom mirror will go where the bottom dot on the circle is, and we'll have another mirror at the top, which the top being the center dot in the image. So we can imagine a mirror on top and a mirror on the bottom, and we can imagine those dots that we see there as being the photon bouncing back and forth, up and down. Okay, so now we're going to take turns playing the part of either observer. So let's say I start off on the platform and you start off on the train. And I know this is impossible, but at first we're going to imagine that the train is passing by at the speed of light. So if we had, let's say, the mind of God and we could observe this photon, which we can't in reality, but we're going to imagine that we're watching this photon, and let's say it's like this ball. We're going to imagine it's in its particle form. So it's moving at the speed of light down, and it's also moving at the speed of light sideways. So for every unit it goes down, it goes across one. So I think you can clearly understand that we're talking about a 45-degree angle now, right? So the observer that's on the platform is watching the ball moving at 45 degrees, or the photon moving at 45 degrees, and the person sitting on the train is observing it going perpendicular.
Mm-hmm.
So Einstein he's guessed, let's say, at the fact that light travels at a constant speed. That's his guess. And he's trying to calculate what are the implications of this. And so he constructs this thought experiment in his mind. And in this case, he's saying, okay, since the speed of light is a constant, if both observers are, let's say, looking at this and calculating the speed of the photon as it's moving along, and they're looking at the distance that it's traveling, he comes up against something, and I think most people that hear of relativity never actually stop to think about, well, what was the thing that he was challenged by? So for practical purposes, I want to illustrate the fact that we can sort of calculate the angle. But because it's impossible for something to move at the speed of light, we're going to make it go half the speed of light. So we've got the same sort of situation where but now the photon goes down 2 units for every 1 unit that it goes over. So you're now looking at half the angle, so 22.5 degrees, let's say, right? So if you were to draw a line from the center, down at 22.5 degrees down to the bottom mirror, let's say, what you would observe is that the light would trace a path that goes down to the perimeter of the circle, but it extends past that because it meets up with the mirror, which is level with the bottom dot. So you can see, just by observing that image, that the observer on the platform is seeing that the light is traveling further because it's moving diagonally than it is for the observer in the train because it's moving perpendicular. So you can see that, right?
Mm-hmm.
Okay. So Einstein's looking at this and he's saying, but the speed of light is constant. So he's wrestling with the question, well, how do you explain this? It's going further for one observer than it's going for the other, but it's traveling at a constant speed. So what's going on? And I think most people don't really stop to think about this, but when you do that, you're in a position now where the question becomes, well, if the speed of light is constant, how do you explain this? Because it's traveling two different distances in supposedly the same time. And the brilliance of Einstein is that he went way out of the box and concluded that the only way that this could work is if time was ticking at a different pace for the person on the train than it was for the person on the platform. And he actually calculated in a very general way how much slower it would be. So you can actually do the math and you can calculate how much slower time must be ticking on the train. So what the observer on the train sees versus the observer on the platform. And I wanted to bring this up because in watching some of the videos that you made with Dr. Wolfgang Smith, it seemed to me that there was a certain amount of clarity that perhaps you didn't have around a current state of physics that made it hard to distinguish basically what he was saying versus what is truly known. Because at one point, he, in talking to that group of, I think there were 4, he made the comment that that his ideas around this icon would overturn Einstein. And I believe it was Jonathan Pajot sort of recoiled at that statement, as did I when I heard it. So I want to sort of establish a kind of a foundation in terms of physics. So when Einstein introduced this relativity, he was looking at the nature of time and space because all of a sudden he was confronted with the fact that time had to be different for different observers in this particular case. What we've just dealt with is basically the train going at a constant velocity and the effects of that. If you make it so that the train is now accelerating as it passes by, we get a slightly different picture. If you had, let's say, we're going to add a few things to the train. We'll add a plumb bob that lines up with where the photon is going, but in behind. And we'll add a square at the bottom to show that the plumb bob and the mirror, let's say that we've got for our photon clock, they square up together. Now, when the train is accelerating, what we would observe, however, is that the plumb bob would be moving backwards because you're accelerating, and it would no longer be going up and down. And the observer on the platform would now no longer be looking at a straight line because the train is accelerating. Now it would be curved. And so Einstein solved the first problem very quickly. He had that done in 1905. It took him another 10 years to figure out how to deal with the accelerated motion. And he probably would have never solved that if it wasn't for his insight that there was no real difference between accelerated motion and gravity. But that's how, from there, he got into basically the idea of curved space-time. Right. In both cases, however, the fact that time varies, let's say, based on the velocity and based on gravity, have been well established. So we know for fact that time does go slower, let's say on a Boeing 747 going across the sky than it does for an observer on the ground. There's been countless experiments that have demonstrated that his calculations are accurate, and therefore his conception of space-time is accurate until something can basically subsume it. But it would have to be subsumed, not overturned, because you still have to account for these things that can be and have been measured. So we know that nature works like this.
Well, the idea of it being subsumed and not overturned is very analogous to the perspective taken by Nima Arkani Hamed when he talks about, he has this wonderful lecture where he's talking about the two mountains of truth. And he shows a picture first of the classical mountain with all of Newton's findings, Newton's theories, and how that was subsumed by the quantum physical mountain in Einstein's theories, but not overturned, because all the classical physics still works. It's still true. But there's a higher truth, if you will. You can stand on top of the second mountain and you can look back at this perfect mountain in the past. It's still perfect. So it's been subsumed, but not overturned. And I wonder if there isn't a little bit of that. Maybe Wolfgang was being a bit imprecise with his language when he said it overturns relativity. I think what he was referring to is this idea that vertical causation, because it's instantaneous, that it is faster than the speed of light. I think that's what he might have been referring to. I'd have to go back and re-listen to the video, but I mean, I've read a lot of his books and I know how he feels about vertical causation being instantaneous. And that in his perspective, vertical causation solves the measurement problem in quantum physics, because any measurement, any observation that takes place has to take place one level up from the level that's being observed or measured. And that is what that's what the scientific world is not taking into account when they are talking about the observer, because they've never really decided yet who the observer is or what the observer is. I was just listening to a conversation a couple of days ago that's taking place at a conference where they're discussing what the observer is. They still haven't figured it out. So anyway, I think that might be where Wolfgang was talking about, which is that's another issue entirely, but we can go back to this thing about Einstein's thought experiment and the idea that time varies based on velocity and on gravity, and that there may come a time when that idea is subsumed, but it won't be overturned because it's already been established by experimental
Yes.
evidence.
So I like to think of it as concentric circles. If you want, Newton is a smaller circle, and then you've got Einstein that extends that knowledge, but it doesn't overturn it. It's still there. It's just, let's say, a special case of relativity. But one of the implications to relativity is this idea that both observers observe correctly. So the person on the train, the observer on the train, would measure that photon moving at the speed of light. So would the observer on the platform. They're both making correct observations. But there's a difference in the rate at which the clock is ticking. And basically, the universe works in such a way that the speed of light is kept constant, and time and space vary around that. So they change so that the speed of light remains constant, let's say. But one of the implications to this is if you allow for every possible observer within the universe, let's say, you come up with this problem that the notion of now, what constitutes now, becomes impossible to really make sense of in the way that we typically think of a moment in time. Because an observer, an external observer to us, for them, now might include a point in our past or in our future, depending on where they're moving, how they're moving. And so it brings to light the fact that, and this was Einstein's idea, that space-time is a whole. Like it's not just a concept, it's the container. It exists, let's say, I won't say independently, because there's Einstein's relativity has both matter and energy in it, as well as the geometry of space-time. But the geometry of space-time itself exists, and it's four-dimensional. So you've got your basically space and time, but the fourth dimension is not just a universal clock that's ticking the same for everybody, the way that Newton would have imagined. It's basically a clock at every point in space-time that ticks at a different pace depending on the conditions. And that, because of that, we have to look at it as a whole. So in one book that I've read, they talk about the space-time loaf. So you could think of it as a loaf. And let's say the person traveling at a higher velocity, if we were to cut it out, the loaf up in, let's say, slices that mean that now, so we were to slice it up and put it together, we would have all these slices of this loaf, and it would make the whole loaf. The other observer would be able to do the same thing, except their slices would be at an angle to ours. It would still span the whole loaf, but the angle would be different, and therefore what constitutes now would be different for them than it is for us. But because of that, you have to have, the whole thing has to exist, or you have to basically negate somebody else's perspective. And Einstein's view was that the laws of physics apply across all of the universe, and therefore there's this implication to it that you've got this whole that exists, this space-time that exists from what we would consider the beginning to the end.
I don't think that would have been a surprise, though, to the theologians or even the early church fathers.
Probably
Because
not.
that's the way that they saw, they believe that God saw the universe.
Yes.
So
Yes, it's very consistent with, let's say, God's perspective on the universe in the Bible.
yeah.
So anyways, now we've got the whole. And if we jump now to quantum physics, and you never did answer my question as to whether or not you've read Schrodinger's What is Life?
Oh, you asked that in an email. Yeah. I've been super busy the last few days. No, I have not read it. I've heard a few lectures where it's been mentioned, and I've heard a few people talk about the implications of it and how powerful that book was in shifting some of the way that people think about things, but I've not read the book.
Okay, well, in one of the videos that you recommended that I watched, I think it was DC Schindler, talks about the necessity of absolute order, or something to that effect. And in Schrodinger's What is Life, he drills down in a beautiful way to the organizing principles in physics. And he breaks it down. He's actually elaborating on a paper that Max Planck wrote, which is appropriate since we're now talking about quantum physics, and he's basically a father of quantum physics. But basically, there's two principles that are ordering principles. The first, from classical physics, is order from disorder, which is that basically as particles interact, they're bouncing around in a disorganized fashion, just randomly. But if you get enough of them together, what emerges is a certain order from that disorder. So all of the classical laws of physics spring from the fact that basically the sheer quantity of particles interacting produce this order on average. That's the one principle. And in Schrodinger's What is Life, he does a beautiful job of showing how that principle could not explain life. And so he pushes it further, and he goes to another principle, which is the order from order principle. And the order from order principle has to do with basically quantum physics, the rules that govern the interactions between these particles. I like to think of it as the rules that the particles embody. So basically, the beauty of his book is that it gives the average reader, let's say, a very deep insight into the boundary between classical physics, which has to do with huge numbers of particles, and quantum physics, which goes down to the individual particles and how they behave. And the idea of life existing on the perimeter or on the edge ties very closely to this idea that I think Schrodinger says that Planck came up with this, that life itself is like a clockwork. But Schrodinger makes it clear that we should take that with a huge grain of salt. And he mentioned, like, he breaks it down. He says that, a clockwork would work on its own and work forever without basically energy dissipating or anything like that. It would just be able to go on forever. And therefore, he's sort of saying that, you know, Planck's idea is good, but it doesn't address this concern that the principle that things go into disorder, the entropy principle, applies universally. And the idea, he questions the idea of the order from order principle because it doesn't take that into consideration. And what I love about Schrodinger's book is that it's before the structure of DNA was discovered. And so he's dealing with things at a general level, but he's doing so in such an elegant way that you get a clear picture of the fact that he understood the fundamentals of DNA before they had been made clear. He understood all of the important principles. He talks of DNA as an aperiodic crystal. And when you look at the structure in detail, you can see that, yes, it actually fits that description perfectly. It is an aperiodic crystal. Now, you might need to listen to or read Schrodinger to be clear on what that means. But I wanted to touch on that a little bit because we've come a long way since then. And I'm going to share a video clip that ties this idea of life around the perimeter and quantum physics together. So
I probably have to stop share first.
Okay.
So that you can share. So you found the share screen button at the bottom of the screen?
There it is. So you can see this okay?
Yes, yeah, I love that video.
You've seen this before?
Oh, I have seen lots of versions of this, yes. It's so beautiful.
I love this, but it brings up, this one brings up the question of, and this is the same structure, just a different video of it. And I've got there's another one coming up. And the last one is this one. I'm going to pause it here. This one is focused on the feet of this molecule. And it shows the small ATP molecules coming in. They're yellow. And they're sort of like, let's say, little battery packs that come in and provide the energy necessary for the feet to reconfigure and therefore walk. It's hard to see, but they come flying in and they connect to a particular spot on the foot. And then you'll see the foot basically reconfigure and move forward.
Now, I have not seen that one before. That is beautiful. That is beautiful.
And this is the mechanism by which the chromosomes are separated when a cell divides. I'll play this as well because it has the same sort of mechanical structure to it, except you see a larger variety of these molecules working and doing something far more complex. And it focuses in on this red area here. And I can provide you like the links to each of these videos so that you can get further details on it. The point, however, is that I want to drive to is that the clockwork the clockwork mechanism that Planck and Schrodinger had envisioned, though I'm sure they never envisioned it like this. It's all there. This is almost purely mechanical. And you can watch the microtubules being built. And then at one point, when everything is ready, it turns green. And then the molecules that are doing the work, once they're done, you can see they just walk away. So you've got basically a workforce of molecules that were doing something, they get it done, and then they walk away. And then here you can see them coming into the picture and moving to the other end of the microtubule.
It looks, to me, it looks less mechanical and more like the workforce in a city. And then they're utilizing materials, and then they are they're sending the materials back to be, you know, remodified and used again, and kind of like recycling plants or something. And you know how it inside the cell, they're always building transport facilities. And as the transport facilities are built and then utilized, then they get taken apart again and sent to another part of the cell to be used for something else. Because they're very, very efficient with the use of resources, right? Which they have to be, because the cell has a boundary. And there's only so much new material coming into the cell every moment as other material is leaving the cell. So all these little processes have to be very efficient. Yeah, it's beautiful.
Okay, so I'm looking to get back here to stop the...
Should be a thing on the top of your screen that's red that says stop share.
There should be.
Well, you might have a different screen. On yours, it might be on the side or on the bottom. I can stop your sharing from my side.
Yeah, did you mind?
There you go.
Anyways, the point I wanted to make was I wanted to bring in the fact that it's definitely mechanical. So we're going down to the quantum mechanics realm, if you want. But as we saw the ATP molecules coming in, what we saw is that classical physics is also involved, because they're basically, let's say, floating around. So it's a diffusion process as well as an attraction process. They're being attracted to the foot, but it's a diffusion process that's basically carrying them in. So you've got a combination of both of the organizing principles in that Schrodinger mentioned at play here.
So you're looking at the order from disorder as being the diffusion, and the attracting as being order from order, or the other way around?
No, that way. The diffusion is order from disorder.
Okay.
So you have both elements taking place there. So in essence, this answers Schrodinger's question about the fact that he mentions the way a clock works, and it needs this little spring to give it a kick of energy. And these ATP molecules act like that spring in that they deliver that kick of energy necessary to keep the mechanism going. So you've got both principles that work together in this environment. The key thing that I want to focus on is the idea that this is a system that's mechanical, but also needs an energy kick, let's say, as a clock would. So in essence, this is a system that is both driven by that energy kick and damped at the same time. So it's a damped and driven system. And this idea of a damped and driven system lies at the heart of chaos. So now we have a natural step from quantum physics into the world of chaos.
Okay, so could you expand on that a little bit more, how the damped and driven system lies at the heart of chaos?
In Gleick's book,
I've had that book for about a year, but I haven't gotten to it because I keep having to read other books.
it's a wonderful book. And damped and driven systems highlight spectacularly in there. He talks about how physics had to, after having proceeded down basically this reductionist road where they went to smaller and smaller pieces of the puzzle, if you want, down to the granular pieces, which is the quantum physics part. But then they found no way to work the way back up. The reductionist approach did not lead to a way to understand the way that these complex systems actually work as a whole. And the calculations were basically intractable. They still are. So they ran into this roadblock. And what it took was a different way of approaching the problem. And in Gleick's Chaos, he talks about, and unfortunately, there's so many pieces in chaos. It's not quite as simple as Einstein's relativity, where you've got one key player.
Yes,
or even
I know. We have hours and hours and hours talking about it. So I know it's not simple to corral.
But he does mention at one point that Feigenbaum, he gives the credit to Mitchell Feigenbaum as being basically the pivot point around which chaos turned, which had to do, and his ideas rotated around universality. He discovered universality in basically non-linear systems. And how he did it was actually remarkable, because he started working just with simple equations that had any sort of non-linearity in them. And he started iterating them. And he discovered that all of these nonlinear systems of equations, well, not systems of equations, but equations, all of these equations that he was looking at behaved in a certain way universally. And he suspected that this discovery extended far beyond just the simple equations that he was dealing with and extended to reality. And the book actually goes into details of various experiments that were conducted that basically show how his thinking in simple mathematical terms extends into reality in the way that the molecules behave, and when you've got enough of them. So when you've got these systems, these basically they're deterministic, they're nonlinear, and the nonlinearity is a big part of this. And he talks says that physicists went back to very simple models, a model of a pendulum that's swinging back and forth and might get a little kick. And what he points out is that when you vary that kick, you might think that you're always going to get the same sort of behavior from the system. It just goes back and forth that periodic, interval, and so it behaves the way we would expect it to behave, and most of the times it does. But it's not guaranteed to do that. There are cases where if the kick's a certain thing, then it will never become periodic. It will be aperiodic. And matter of fact, Leake pretty much ends the book tying it back to Schrodinger's idea of the aperiodic crystal and showing the connection between nonlinear systems and the generation of aperiodicity and how that connects to basically the underlying mechanics of life. And so I wanted to try and use this icon of Dr. Smith as something that kind of tie everything together. So we've got the image of the photon clock that we created, and then we looked at the molecules walking along the perimeter, and the idea that that's where life is, along that perimeter that's down at the level where quantum mechanics and classical mechanics play together, let's say. And then you take the ideas of universality from Feigenbaum, and you make one more observation, and that is that when Mandelbrot first started plotting the Mandelbrot set, it wasn't like today. He couldn't just go to a modern computer and see the whole thing and zoom in and stuff like that. He was printing it out on paper, and
it was an old dot matrix printer too.
That's right. But he observed as he was printing it out that in what's called the needle,
I do have, I got an interactive one. Do you want me to bring it up?
Maybe I'll take over for another moment.
Okay.
I have an image here that I should be able
While
to
you're
share.
bringing that up, one of the things I wanted to say, one of the principles that I operate off of all the time is that boundaries and edges and limitations are the places where all the creativity takes place. So when you talked about the perimeter between quantum and classical and where they play together, it's that playing together, that edge between the two where all the creativity takes place. And of course, in the Mandelbrot set, it's the same way. It's the edge where all creativity takes place. And that's true. Well, I learned it through art, but that's true through every, you mentioned consilience and all the different perspectives, all the different domains of knowledge. That's true through physics and biology and chemistry and history and philosophy and everything else. The boundary is where all the beautiful stuff is happening.
Yeah, so, and the border between order and chaos, which is actually, if we're talking about icons, to me, the Mandelbrot set is an icon, and what it reveals is the beautiful complexity that lies at the border between order and chaos.
Yes, yeah. Are you in or out? I like that illustration that you used in the book. Are you in the set or out of the set? And yep. So that's the needle right there, right?
Yeah, this part is the needle. And this is basically a model of the period doubling cascade that Feigenbaum discovered. And it shows how the relationship between, there's a tight relationship, though I don't know where it came from. There's a tight relationship between the Mandelbrot set and this period doubling, this diagram of bifurcations and period doubling that Feigenbaum discovered. And so you've got this neat tying of something that's quite visual with a very abstract idea, but they coexist. So to me, the final thing, if you want, is that if you take the Mandelbrot set and you place it into Dr. Wolfgang Smith's icon, you have to rotate it by 90 degrees, but then you can place, if you make the line basically a length of 2, then the Mandelbrot set fits perfectly in there, and you've got all 3 of the revolutions in physics that took place in the 20th century, all sort of captured within that one icon.
Now all we need to do is get an AI to make us an illustration of that, right?
Yeah, that would be something.
Well, I play a lot with this idea of the elements and principles of art and all of those intersections and how they tend to map onto everything. And it's very complicated to explain. I've not written my book. You took the time and the effort and the energy to sit down and write the book, and I have not written my book, but I thought one time maybe I could explain it to an AI and it could make me an illustration. But it came up with just things that were completely useless, not unexpectedly, because if I can't articulate it to a human being, how can I articulate it to an AI, right? One thing I wanted to bring up before we go on, you were talking about the diffusion and the attracting and the order from disorder and the order from order. And that reminded me very much of this other binary that tends to show up everywhere between accuracy and expression. So the order from order would be over on the accuracy side, and the order from disorder would be over on the expression side. And that tends to be a kind of a binary that where you can pretty much map out the world on that binary between accuracy and expression. At least, let's say one axis, because it doesn't work with Christopher Avery's idea of responsibility and coping, because responsibility and coping is more like responsibility is above, is the one, is Peter walking on water, and coping is everybody else that's drowning because they can't walk on water. So
yeah, you end up with let's say a distinction here between a qualitative difference and a quantitative difference. In that respect, it was the idea of coping is basically a certain mindset, and it comes with many faces. But they all share something in common, which is, I don't want to necessarily say the abdication of responsibility as much as the not picking up of responsibility. They're very closely related, but there is a distinction. But I kind of feel
I think one of the things that hit me when I was reading your book is that, you know how Peterson always talks about Satan in Paradise Lost being the one who says, rather than seeing being as good and accepting that the unknown exists, Satan says, I know everything I need to know. I don't need anything outside myself. And so he denies the unknown and
denies possibility.
Yes. And to me, that's what happens with responsibility and then all the coping mechanisms, because the coping, you know, obligation, shame, shifting blame, all those things that are down there in the coping world Those are ways of saying either fear of the unknown or a denial of the unknown. I'm not going to face the unknown. I'm not willing to go there. And Peterson, in his wonderful conversation with Roger Scruton, when they're talking about the transcendent, Peterson likens the unknown, or likens God or the transcendent, to what you meet when you come to the limit of your knowledge. When you are stepping outside your knowledge into the unknown, that's where you meet the transcendent. Or in another place, he says the transcendent is what you meet when you err. And to me, that's the distinction then between responsibility and all these other things, because responsibility says, I'm willing to take on the risk of facing the unknown. And that's what you have to do when you're taking on responsibility. And then all these other things are, I'm not willing to take on the risk of facing the unknown, so I'm going to find some other way to solve my problem, whether it's alcohol or finding somebody else to blame for my problems, or victimization, or some tight ideological worldview that's going to protect me in my own little casing, so I don't have to face the unknown.
And in essence, you're not solving the problem.
Right.
It's literally the not picking up of the problem and resolving it.
Mm-hmm.
You might not, in all cases, you're basically, it's a denial of the possibility that you can resolve it. And if you want, responsibility shares a lot in common with the idea of faith, in that you're operating from a different set of assumptions. In responsibility, you must operate from the assumption that you can solve it. If you're only coping, you're operating from an implicit assumption that either it can't be solved, or that you are incapable of solving it, or something along those lines. But you're operating, in each case, you're operating from diametrically opposed fundamental assumptions.
Mm-hmm.
And it's the nature of those assumptions that really distinguishes between those two mindsets.
Well, and I think this is a longer story maybe for another time, but I think that what's in that intersection there is hope. And hope is kind of connected to the idea that being is good. Because if you can, like Peterson always says, basically, in order to take on responsibility, in order to voluntarily face your fears or voluntarily face your problems, that you have to believe that being is good. And I think hope is sitting right in there. It says that faith is the substance of things hoped for. And why I say this is a long story is because there's this beautiful passage in Genesis chapter 1, verse 9 that says, first God divides the water from the water, the light, and then the water from the water. And then it says, and then he gathered the waters so that the dry land could appear. But that word gathered in the Hebrew is translated it's in many other verses, but in every other verse where it's translated, it means to wait or endure or hope. But in that one spot, it's gathered.
Well, that's interesting.
And yesterday I was having a conversation with a young man about the book of Job, and he has done a deep dive into Job and made like 20 episodes going through the book of Job verse by verse, and learned a lot from that. And he was reading one of the passages from Job where it talks about where God is speaking to Job and says, don't you see how I restrained the waters when they burst forth from the womb, and I set a lock and barred the door, and then I used the deep dark as swaddling bands. And so basically the picture that's being drawn there is of gathering up the way you would wrap a baby and then hold it in your arms. Well, if the waters are the chaos, and at the beginning of time, God is gathering them up and holding them like a baby, that baby is hope. And that's the possibility that exists in the chaos, because all the treasures are hidden in the chaos, not in the known. You know, the treasures aren't hidden in the walled city. They're hidden in the chaos outside the walled city. So I think there's something pretty goes down many, many levels there.
It's interesting to use that expression, many, many levels, which is basically the idea of fractals
Yes.
and universality tie into this this idea. And Feigenbaum expressed his ideas, I think, to James Leake, where he was talking about the fact that he had wrestled with reductionism and had done and attempted to do the math from the lowest point and trying to work up, and came to the conclusion that that wasn't doable. You had to change the way that you thought. And from his perspective, what you had to do was you had to look at scaling principles. What scales from the smallest? What's the relationship between the small and the large? And his final conclusion was that the only things that can possibly be universal, truly universal, are things that scale. And therefore, you have this pattern of smaller to larger in the way that they relate to each other. And that's.
I have to ask you, have you seen any of Michael Levin's videos?
I watched a couple, one or two, I think, that you had done with him, and maybe a couple that he had done. But he's brilliant. And
well, one of the people that he talks about that has kind of defined his search in the work that he's doing is a guy by the name of Darcy Thompson. D''RC Thompson. And Darcy Thompson, I guess, wrote this book. I tried to buy one, but they're like $800 because it's not in print anymore, and you can only get old collectibles. Darcy Thompson had this idea that if you almost like taking the block universe, right? If you make a block, which Levin would define as morphospace, you have a block of space that's filled with possibility. If you put inside that block a fish, just an ordinary fish, and so the fish is kind of graphed into the way that it's all measured in this block. It's all inside this block. Like if you froze a fish inside a block of ice, maybe. Only this is a malleable block that you can work with. Now, if you deform that block by twisting it or by pulling it or by stretching it, when that fish gets pulled or stretched, it all of a sudden becomes another kind of fish. And so he actually did the calculations, and he did drawings of deforming these shapes along these graphing points, and many of the different varieties of fish are just deformations of the one design. So you have a basic design of a fish, and then you deform it this way, and you get this kind of a fish. You get the bullheaded fish, you get the long skinny fish, you get the really high fish with the funny tail. It's really weird when you look at it. And so there's this idea that maybe all of the different forms that are there are, it's a very Platonic idea that there is a form, and then all of the other forms that come out of that form are just manipulations or adaptations on that form based on the way that it moves into space as it's developing. So what is, in your words, what is driving it and what is damping it? What's inside of it pushing out and what's outside of it pushing in the environment is affecting the shaping of that organism.
Yeah, and as a matter of fact, Darcy Thompson's ideas feature quite heavily in Leake's Chaos.
Oh, so, okay. Well, there you go. There you go.
Yeah, he talks
There's
about
the overlap.
The idea of universal form, and basically the underlying the need for the underlying mechanism to be simple. So basically, simplicity plays a very important part in complexity.
Yes.
Something like the Mandelbrot set is a great example of that. You've got the simplest of processes that yet somehow produces infinite complexity and never repeats itself. So it's generative. It produces new forms and new structures, and yet it's just one simple process, very simple process.
Mm-hmm.
And
well, so let me just walk you through, and this is something I talked with Jordan Hall about too when I had my conversation with him, but just briefly walk you through kind of my picture of how a painting takes shape. So the artist has an idea in their head, and then they're going to, where that idea comes from, that's another question, but you have this idea. Now you have your material substrate, your canvas or your paper, whatever. You have your brushes, you have your paints, but mostly you have this idea. So the idea operates through your body. You pick up the brush, you dip it in a color paint, you put it on the canvas. Well, now, in order to get the next stroke on that canvas, that first stroke has gone in through the eye gate and is interacting with the idea. Are we there yet? Well, no. So I have to add another stroke, but the next stroke changes what's on the canvas so that now when you look at it, it's a new image. So it's this constant iterative process of putting down a stroke, trying it, reacting back with the idea, the original idea, and then putting down another stroke. And over time, that's how a painting takes shape. And whether it's a representational painting or non-objective or abstract, it's the same process all the time, because you're working through the human person is kind of the iterating principle of the original idea. And there's a wonderful book by Dorothy Sayers called The Mind of the Maker, where she breaks this process down into the idea, the energy, and the power. So you have the idea, and then the idea is instantiated or manifested through the energy of the maker, the worker, the artist, whatever, that energy. And then once it's complete, the power doesn't happen until the image is complete. And the power is that image is now articulating or communicating the original idea, but in this new format to others. So the way in which it is communicating that idea, that's the power. So like if we take your book, you had the original idea that grew out of the three eras of your life, kind of intersecting with all of these other things that you'd been studying. And then you had the energy working of your life and that energy working of writing the book. Then you completed the book. Now the power is in the book itself, because the power lives, the book lives beyond you. It lives in the minds of people that you don't even know right now, happening, wherever it's being read. And then that power is the communicating. Well, she goes back and she connects the idea to the Father, and the energy to the Son, and the power to the Holy Spirit. So the Father is the one that expresses the idea. The Son is the one who is active in the world, and then the power is the Holy Spirit communicating that idea, which has become actualized through the energy, manifesting that power. And so that was a pretty interesting overlay too.
Well, it's interesting that you bring that up. In a sense, I connect more with the idea of being an artist, or as Jung might have put it, an intuitive.
Mm-hmm. Mm-hmm.
And there's actually a quote that it's actually from Marie-Louise von Franz. I haven't read anything of hers, but this came up on Twitter. And it says that intuition needs to look at things from afar or vaguely in order to function, so as to get a certain hunch from the unconscious, to half shut its eyes and to not look at facts too closely. If one looks at things too precisely, the focus is on facts, and then the hunch cannot come through.
That's a beautiful quote. I love that.
And I know from having taken something that categorizes you into Jung's classifications, let's say, that I am an intuitive in this sense. And I have a hard time communicating with those that are more of the scientific bent, because they go into the precision that I don't really share. I'm looking at things from dots that connect. It's like these dots connect here. And so like even this, the connection between Jordan Peterson's ideas and maps of meaning and the process that generates the Mandelbrot set, to me, it was like when it came to me, and it did just kind of come to me that these things are related. And I looked at it.
100%. Because that process, when Peterson talks about the process that connects order and meaning, or that's at the intersection of order and meaning, and I've written 3 or 4 essays on this, but I've never published them or anything. That is the artistic process. That is the artistic journey. That is that boundary where all the creativity lies. That's exactly what that is. And then the Mandelbrot set is just an illustration of how it works as an iterative process, right? And
yes.
then the process and the product are 2 separate things.
The fact that he's been specific enough that there's a really tight correlation between this process that he describes, which interestingly enough is, in his terminology, Christ. So he's describing this process, but at the same time, I've observed that when he talks about it, he doesn't have a clear picture of that boundary between order and chaos from a scientific perspective, because that boundary is intricately complex and structured. And you could say infinitely complex and structured. And so his ideas are they're spot on, but they're still somewhat implicit in him, in that when he really narrows down on that, he talks about a narrow, straight, razor sharp edge. And it's like, okay, at that point, it's like he doesn't know quite what he's pointing at. He's correct in all aspects.
Well, because even a razor sharp edge has all its little fractals.
Well, yeah, if you go down to the atomic scale, let's say. Right. But you can see that he's clearly pointing at something, and I believe the way that he's structured it, he's clearly pointing at the same process. And that's the thing that I sort of marvel at, is that you can tell that he sees it. You can tell from the description that he knows what he's pointing at, and yet he's maybe one book away from being able to really see it. If he read Gleick's Chaos and got a clearer picture of what that boundary really looks like, and the structure that lies in that boundary, I think he'd be blown away. And I think it would greatly improve his overall thinking about that process. And that's, we had a fairly long introduction with that icon, but the icon leads to basically what ties our understanding of quantum physics and brings it up to our scale is chaos and universality, and the connection with the Mandelbrot set, and then further connection with the process that Jordan Peterson describes. And now you've got a connection between physics and, let's say, psychiatry or psychology. And I think also with using Dr. Smith's icon, you also sort of have philosophy in there.
Mm-hmm.
And even if you go down to like, and I have got little knowledge of philosophy, but the idea of the Platonic shapes.
Mm-hmm.
I think if you read Chaos, the ideal in terms of Platonic shapes has been, let's say, implicitly understood but pointed at incorrectly. So you start off with circles and squares and triangles and that sort of stuff, and you might progress to more complex shapes and stuff. But the true underlying shape is described in Deleuze's Chaos in the attractors in phase space. And I know you haven't read the book, but it's worth reading if you want, just for that. When you get to the strange attractors, which are infinitely repeating yet never perfectly so, they're like the Mandelbrot set. The patterns repeat infinitely, but they never duplicate.
Mm-hmm.
So they're always similar, but not perfectly so, what we would call perfectly so. So you always have variance and variation within that. And it's the tying of all these ideas together that it strikes me that it's tremendously significant, especially for the current time, that this separation between the objective and the subjective are falling apart. And there was something that that Michael Levin, I think he was even quoting, where he talked about the sentience of physics and the physics of sentience.
Mm-hmm.
It was, at that point, that's kind of like the final dot that allows you to see that if you take physics and you constrain your ideas to the known so that you're not being distracted by the speculative and the purely theoretical at this point, but you constrain your thinking to the known as an artist would constrain their work to a particular medium or something. As you constrain it, you get basically the same story that's told in the Bible, but from a slightly different perspective. So with general relativity, we have the idea of the Big Bang emerging. And with the idea of the Big Bang, you have basically an initial state of the universe that had to have been extremely ordered. And we're in the arrow of time takes us from extreme order down to basically maximum entropy, which we're a far ways off. But so you have this flow in that direction, and if you ascribe sentience to physics, now you put it together, now you've got the story of the universe, but it's an aware universe. It's conscious. And if you borrow just a little bit from the Bible and say, okay, if God were speaking, what would he say, kind of thing. The story that it tells you is that if, let's say, prior to the Big Bang, you have God unified. If you allow that there was a choice made to reveal himself, and the Bible is really about God revealing himself to man, then you have God basically revealing himself, but in such a way that God must sacrifice himself to make us manifest, basically, because you're going from, let's say, almost perfect order down to maximum entropy, which is essentially death. There's nothing new taking place at that point. So you have this history of a God that, to bring us into being, must sacrifice himself, in a sense, and provide us with that life. And we feed off of, and this is another thing that Schrodinger elucidates quite well, is that we feed off of order. So the principle of order from order is order maintaining itself and creating more order, but nevertheless moving in the direction of increased entropy all the time and irreversibly. So you have basically the same sort of story, a different framework to it, but you have God sacrificing himself to provide life and existence as we know it. So to me, it's...
Well, let me just clarify here, because if I take you just at the literal level, it sounds like you're saying that the substance of the universe is God, which would be a very pantheistic perspective.
Well, it would be pantheistic if you assume that particles, let's say, are like grains of sand. They're lifeless, or they're not part of that intelligence. Then that's correct. But what we know through physics is that all particles have basically this dual nature to them, and the way that they're constituted, their interactions account for life, if you want. So there's an intelligence, and it's like life is built into the system. It's not that intelligence and consciousness emerge so much as they are built in.
Fundamental.
Yes, and because of that, I don't think the view is pantheistic.
Well, I was just trying to clarify when you said God sacrifices himself to make the universe. Just from a strictly literal picture, that is God in his, first of all, does he have substance? I'm not a theologian, but I mean, if you're thinking literally, then God becomes the substance of the universe, which would mean that God is no longer in the picture of the the original theologians and the church fathers and so forth. God is both transcendent, outside of the universe, looking at this block universe of all time at one time, because he is outside of space and time, but he's also inside the universe, because as it says in so many places that all things are knit together in him, in Christ. So he is at all times knitting everything together. So he is both inside the universe, knitting everything together at all times. I mean, every breath that we take is coming from him. But at the same time, he is outside the universe, because he is the one that has created space and time. So, but if I take literally what you said, it sounds as though you're saying that God used himself to create the universe, and so now the universe is him.
Yeah, that's probably fairly accurate. If you think of
that's an accurate representation of what you're saying, that the universe is God revealing himself.
Yeah, I don't, and my thinking has changed from that of a Christian to I don't know what I am now. But I don't fit into the box of Christianity, let's say. so when we talk about God, if you look at Christ says to his disciples after they requested that they be allowed to see the Father and just show us the Father and we'll be satisfied. Jesus answers, you know, if you've seen me, then you've seen the Father. And so Christ, in sacrificing himself so that we might have life and that more abundantly, you have the same story being repeated, but at a different level. So you have God sacrificing himself so that we might have life, literally, so that we might have existence. And so physics to me.
If I just take that verse though, when Christ is saying that to them, he hasn't gone to the cross yet. Now, in terms of the cosmos, the lamb was slain before the beginning of time. Lamb was slain before the worlds were created. So the lamb being slain is a given already. But when he's speaking to them, he says, you know, if you have seen me, you have seen the Father. I take that to mean him as he was right then at that moment, that he is the image of the invisible God. Whether that image, part of that image is his sacrifice on the cross, which takes place subsequently. But when he's talking to them about that verse, that's only a part, that would only be a part of what he's representing to them. It's also his action in the world as he, you know, during the time that he lived on earth, he's also a representation, an exact image of the Father. So everything about Christ, as well as his sacrifice, his incarnation, his life, his sacrifice, his resurrection, all of that is an image of the Father. I mean, that's the way I would take it.
Sure. And the only thing that I would say to that is that bringing time into the picture is a little complicated because Christ often talks as though that's his purpose will be fulfilled, or there's a sense in which it's guaranteed, though also that the possibility of it not unfolding is never denied. It's a strange paradox, let's say. And it isn't until he's on the cross and he says it is finished that it becomes, let's say, guaranteed, that it's played its part out in reality. Yeah, but I know that I'm breaking all the rules in terms of defining God as pretty much the manifested universe. But I think science is quickly coming to an understanding that you can't separate sentience from physics. And you can't divorce consciousness. Like, you can't say that consciousness just emerges. That, you know, the great thinkers that I've read have all sort of concluded that consciousness underpins everything. So you're not going to get below that.
But then that wouldn't necessarily have to be pantheism, though. That could be panentheism. It could be panpsychism. You know, there are many different approaches that those thinkers take. McGilchrist is, you're familiar with Ian McGilchrist's work? Yeah.
A little bit.
So he would call himself a panentheist, I think. That is not that God is the world, but God is definitely in the world. And so God could be in the particles, lending sentience and consciousness to the particles, but not be the particles. So I mean, there's a lot of different ways that could be parsed out. And by the way, I'm not the least bit worried that I'm not I'm not trying to say that you're not lining up with some perfect image of something. I'm just trying to be clear about what it is that you're saying. That's all. I'm not trying to argue with you or trying to say that my picture is better. I'm just trying to line up where the differences are so that we can understand each other. Because I think we could have some more fruitful conversations in the future. But I want to clearly understand the picture.
I'm going to go back to that quote about intuition needing to keep a certain distance from the facts. So I don't really bother trying to get clarity around which category, let's say, that this idea falls into. For me, if you bring all of modern physics into play, then you're thinking about inanimate objects, let's say, is no longer the same as it was even 50 years ago or 20 years ago. You have to account for something that's different. But and to me, the intelligence is built into the rules that are embodied by the particles.
No question, 100%.
So even like, and some of the rules are absolutely amazing. Like if you look at not all particles interact with other particles in the same way. They embody this set of rules that are defined in quantum physics. But even simple little things like the fact that photons don't interact with each other. And you think of the implications of what would happen if they did. And if they did, they'd be bouncing off of each other. And so what we wouldn't be able to see because they'd just be scattering each other and you just get noise. And so you get this simple little rule that they don't interact with each other and therefore we can see clearly and they come streaming to us and our bodies have the capacity to detect them and decipher them and create meaning from what is outside of us. And though it's even that distinction, outside and inside, the separation between us and our environment is something that's good in terms of an idea to work with, but it's misleading. There's a huge interplay between us and our environment, kind of like the fish in the water and the ice being deformed and stuff.
Yeah, well, and it's what the cognitive scientists now are calling niche construction. And however, we're at about almost 2 hours now, so we may be stretching the limits of the people who are listening. So maybe we should plan to have another conversation because we haven't even cracked the pages of your book yet. Because I really did just appreciate so much the way you put things together in your book. And because I have the same kind of mind as you do, I think, where one of the things they teach you to do as an artist, if you're trying to clarify the values in your painting, is to squint enough to where you're only getting about half light and half visibility. And then the pattern becomes very clear. Okay. The facts do not become clear, but the pattern becomes clear. And I think that's your quote on intuition is a brilliant evocation of that idea. And so you and I are people that see patterns in mathematics, in physics, in philosophy, in whatever it is we're listening to. Something will come in and it'll go, oh my gosh, that fits in over here. And so we have all these pieces that fit. Well, the way you did the book was you lay things out in such a way that when all of a sudden all the patterns all line up, it's kind of like when Jordan Peterson talks about music and how at that moment in the symphony, when everything just lines up and stacks up on top of each other, that's where the meaning appears. Well, that's the way you wrote the book, kind of like a symphony. And
it's nice to hear you say that. The book was a huge challenge. And your ideas are about art, I think, tie into this, like especially the ideas of constraints being imposed. So yeah, we haven't stepped into the book yet, but the tying of, perhaps I did this partially because this is the direction that Jordan Hall was most attracted in, was the whole Trinity idea. And really the discussion on physics and that icon, they lead to the first chapter basically. Though at the time I didn't really put much weight on what amounts to be, you know, the stuff in chapter 3. To me, chapter 3 was more or less, and I'm using Jordan Peterson's ideas to guide everything here. And chapter 3 is sort of like, this is what constitutes a proof in this mythological construct, let's say, and it's basically giving authority to chapter 1.
Well, so the next time we talk, let's kind of narrow our focus maybe to chapter 1 and chapter 3 or something like that. We could just narrow our focus down and just look at one aspect of it, because it does cover the universe. It's a little bit hard to tackle the whole thing in an hour and a half, but I would be more than interested in. I told you in the first chapter, I probably took notes on every paragraph, because like, oh yeah, that fits in over here. Oh yeah, I see what he's saying, and that lines up with this thing over here. And so I mean, and but I've read the whole book and gone to the end and then gone back and started again on the middle, and I think there's just a lot there. I will put a link to the book in the notes so that people can buy it if they are interested, and maybe we can schedule another talk in the future.
Okay, and perhaps we can use your questions about, or any questions that you would have about the book, as the driving force.
Yeah, sounds good.
Okay, well, I appreciated this opportunity, though I still feel that it was sort of awkward. I don't talk much.
What felt awkward about it? I certainly don't want people to feel awkward when they're talking to me.
I just feel like I stumble along, because I don't really get the opportunity to talk about the ideas much, and therefore, unlike, you know, somebody like Peterson, who, you know, repeated his talks over and over and over again, and, you know, now they're just polished and worked out. I'm at the very beginning of this, and I struggle to articulate the ideas, really. And
I think you're doing good, though, and the more that you articulate them, the more that they'll start to flow for you, because you certainly articulate them well in the book. I think part of what makes it difficult to do when you're in conversation is that a question comes in and immediately the whole book pops up inside your head, and you're trying to, how can I answer that question with this book in one sentence? You know, it's a combinatorial explosive problem, right?
Yep.
Yeah,
I agree.
That's what makes the communication difficult. It's kind of like, I took Spanish in high school, I took German in college, I took French in my graduate work, and then I moved to Japan and lived there for 3 years, learned Japanese intensively. So, and I've been gone from Japan for 30 years. So I can't remember the Japanese. I was in Quebec recently, and after about a week in Quebec, enough of the French started coming back that I could read signs, and I could read even articles in newspapers. I could, I can read more than I thought I could. But if I started trying to speak French, the Japanese would poke in there, the Jews would poke in there, Spanish would poke in there. So yeah, I get it. It's hard to articulate when you have too much stuff in your head. So let's talk again soon, and I look forward to it.
Sounds good. Thank you.
Okay, you have a great day.
You too.